to.
Okay, so let's get started.
Yes, let's get started. Okay, first off, we've got like kind of the last of the 60% GH60 keyboard cases. One of the things that drives me nuts is when I'm doing a project and it's like, oh my goodness, I need an enclosure, and designing a board after the enclosure is a lot easier than designing a board than trying to find an enclosure to fit it. So I bought a bunch of 60% cases in like translucent plastic and milled aluminum. This is kind of in the middle. It's plastic, it's injection molded, but it's a much nicer injection molded plastic one. It's got these cool like ribbings in it. It comes with like a spacer kit. It's designed for the kind of the Geek Hack 60% keyboard. It's got all the holes in the slots. We also have a metal plate that can go with it.
You want to show it on the overhead?
Fast. Maybe why not? Get a little bit of space here. So we do have, this doesn't have the PCB, of course, but, let me autofocus, lock. This does have the metal plate that you would use between the PCB and the keys to strengthen it, so it's made out of aluminum. And then we also have like a little foam padding if you want. And this all, of course, has the holes in the right location, so it's a lovely way to make a custom keyboard. You just add the PCB, and this is a very, very common layout. A lot of people who are making keyboards, they start with the GH60 because it's a complete keyboard. It doesn't have all the extras, but it has enough for you to use, and you can see like return and shift and space and all the alt and commands and number keys at the top as well. There you go. Make your own keyboard with this very nice, kind of like a metallic look, but it is plastic keyboard shell.
All right, next up, we're selling circles.
We're selling circles. This is, you and I love ring lights. So this is the innards of a ring light. We have actually it in two versions. So this version, it's comes with a USB cable with an on-off switch. This is kind of like no thought required, just plug and play.
Yeah, it just works.
Plug into USB, and you get a very thin ring light. Grab the light.
Yeah, so we got this one, and then you could also just have the circle.
Yeah, so we'll show it. It's bright.
Triangles are extra. Okay.
Triangles are extra. Okay, so let's go to the front camera, actually. So this is the ring light. It's pretty simple. I mean, you give it power over USB. It's got a resistor. It does get a little bit warm. Of course, you can, with the bare one, you can solder it and power it, PWM it. It's not addressable, right? The whole thing is on. But if you want to make a, LED ring light, it's a common thing in like costuming, or if you're doing like photo effects. I don't know. It's thin, it's small, it's simple. Go for it. Do watch it. It does get a little hot. You may want to change out the resistor or give it a 4 volts if you'd like. It does run off of 3.3 volts, a little dimmer, but you can do that as well.
Okay, and that's both of them, right?
Yes, that's both of them.
Okay, so then let's do the star of the show tonight. Besides you, Lady Ada, and our customers and our community and our staff here.
Yeah.
It is
the LED driver board for the LED glasses panel that we released last week. These will be in the shop very, very soon. We're just wrapping them up. But it's kind of like a cross between Itsy Bitsy and a feather. But it doesn't have any GPIO. It's meant to be very slim. And it's designed for the LED glasses, but I'll tell you, it's actually kind of a nice dev board if you just want a Bluetooth programmable dev board that's very slim and very minimal. And it has a couple of things built in. So if you...
do you want to...
Well, this is it driving the
glasses.
Hold on. Oh, wait, I turned them off. There's an off switch. Hold on. There you go. Okay, good. So I'm modeling. Who are you wearing? I am wearing the LED glasses driver.
Yeah.
The glasses driver is on the side here. And again, it's designed to be very slim, so it sits on the side of the glasses. And has a STEM QT port, so it plugs in. You can then plug it into your LED glasses through a STEM QT connector. It is just an nRF52840 board. We love the nRF52840. It's a Bluetooth module. It's Arduino compatible. It's CircuitPython compatible. It's very powerful. BLE is supported by every mobile phone, many laptops, desktop computers. So let's go to the top down and I'll show the details. Okay, so here's what we get, because it is a little bit interesting because it's not a standard format. So again, it's as slim as possible. On the right-hand side down here, there's the Bluetooth module. So we've got the certified nRF52840 module. Right here, there's a little mini NeoPixel, so you can do RGB indicating on the side. It's good for like the bootloader and stuff. There's also a single LED called LED for blinking. On the bottom there is a 2 megabyte QSPI flash, and so that's used by CircuitPython for file storage. You can also use it by Arduino. Above that is an accelerometer, so you can use it for tilt and motion sensing. Above that is a microphone, a PDM digital mic, good for if you want to do like machine learning projects, very minimal ones, audio reactive projects. There's an on-off switch, so it'll turn on-off power to the entire board. There is a battery connector in the center there for LiPo batteries or AAA battery packs. I'm using a AAA battery pack. So there's a LiPo charger circuit, but it's not activated by default. That's because you kind of have to pick one or the other. Either you're going to have LiPo charging, or you use alkaline batteries or nickel metal hydride batteries. But you can't have both because the LiPo charging circuit should not be active. You know, if you have LiPo charging and you have a non-rechargeable battery, you're pushing current into the battery. It's not a good idea, especially with alkalines. It could damage them. They could leak. And so by default, the LiPo battery is not activated. The LiPo charger. So if you go to the bottom of the board, which is the next photo, you'll see on the bottom there's a little thing that says optional LiPo charge. You short that closed with a bit of solder, and that will put power to the LiPo charger. Voila, you can now use LiPo batteries and charge it through. But we thought for the glasses purpose and wearables purpose, a lot of people don't like using LiPo batteries. Okay. Then even more to the left, there's a reset button, and then there's a right angle button labeled SW. That's a user switch, so you can click or double click to have it select things. USB-C for programming it, debugging it, dragging files, charging up the battery if you want to use it. And then all the way to the left, there is a STEMMA QT port. So that's what you would plug into if you want to add external sensors or devices. And then there's 4 slots that you can use to attach it mechanically to whatever you're doing. I mean, it's designed for the LED glasses, but I think there's a lot of people who are like, I just want a simple, small Bluetooth Low Energy board. I can program it with Arduino. I can program it with CircuitPython. It's the well-known nRF52840.
Yeah,
it's got
USB-C.
Battery charging, USB-C, on-off, and just a couple sensors, right? Just enough that I can do motion projects or audio projects. And then over the STEMMA QT port, which our Feather and ITZY don't have, you can add other sensors if you'd like. So I think this could actually be a good dev board for other wearable projects as well.
All right.
Yeah.
And that's new products.
Yay! Where are my new glasses?